The divine mystery of numbers. Since the dawn of human civilization, numbers have fascinated us. From tally marks carved on bones 40,000 years ago to the most advanced equations of modern physics, mathematics has always been more than a tool. It has been a language, a code that seems to describe the very structure of reality itself. But here lies the great mystery. Did we invent mathematics as a convenient system to measure and calculate, or did we discover it, as if it already existed, waiting for us, eternal and untouched, like a divine truth? Many great minds have wrestled with this question. Galileo once declared that the universe is written in the language of mathematics. Albert Einstein called mathematics a miracle we cannot fully comprehend. The mathematician Roger Penrose even suggested that numbers and equations exist in a timeless Platonic realm, a dimension of truth beyond human perception. This raises a profound possibility. What if mathematics is not simply a human invention, but the very thoughts of God? What if numbers and patterns are the fingerprints of something far greater than us? An infinite intelligence woven into the cosmos itself. In this series, we will explore the strange and sometimes terrifying ways mathematics reveals hidden truths about our universe. From the golden ratio found in galaxies and seashells, to prime numbers that behave like coded messages, to the shocking fact that many mathematical constants are perfectly tuned for life to exist. We will ask, is mathematics proof of a divine mind, or is it just the most beautiful illusion ever created by humans? Part 2. The Code of Nature. When we look closely at the natural world, something strange becomes clear. Nature itself seems to obey mathematical laws with an eerie precision. Take the Fibonacci sequence, for example. A simple pattern where each number is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13. At first, it seems like just a quirky sequence of numbers. But when you step into a forest or a garden, you realize that nature has been using this code all along. The petals of flowers, the arrangement of leaves, the spirals of pine cones and sunflowers, all follow Fibonacci. Even hurricanes and galaxies curl in spirals that reflect the golden ratio, a number deeply connected to this sequence. Why would seashells, storms, and entire galaxies echo the same mathematical rhythm? Is it just coincidence? Or is this evidence that the universe is following a script? One written in numbers? Scientists sometimes explain these patterns as efficient growth or optimal packing. But such explanations only raise deeper questions. Why is efficiency itself built into nature? Why is it mathematics and not chaos that rules the dance of atoms, DNA, and stars? To many, this is a sign that mathematics isn't something we impose on the world, but something that is already there, woven into reality at the most fundamental level. It's as though mathematics is the operating system of the universe, and we, by studying it, are glimpsing the hidden architecture of creation itself. Could it be that every tree, every wave, every spiral of a galaxy is silently whispering the same truth? That mathematics is not invented, but discovered? That it is the universal language, the very thoughts of God? Part 3. The language of the universe. Imagine for a moment that you're an alien civilization trying to communicate across the galaxy. You don't know our words, our culture, or our symbols, but there's one thing you would understand: numbers. 2 plus 2 equals 4. No matter where you are in the universe, the ratio of a circle's circumference to its diameter, pi, is always the same, whether measured on Earth, Mars, or a distant star system light years away. This is why scientists call mathematics the universal language. It doesn't depend on culture, history, or even biology. It's something far deeper, something woven into reality itself. And when we use math, we aren't just describing the universe, we're speaking in its own language. Consider Einstein's famous equation, E equals mc squared. With a handful of symbols, it unlocked the hidden relationship between matter and energy and revealed the secret engine of stars. Or think of Isaac Newton, who used mathematics to explain the invisible pull of gravity, the very force that binds planets to the sun and keeps galaxies from flying apart. These aren't just clever tricks. They show us that the universe can be decoded, almost as though it were a book waiting to be read. But who wrote this book? That's the question that has haunted philosophers and scientists for centuries. Was mathematics created by humans to describe reality? Or was it already there, embedded in the cosmos, waiting for us to discover? Galileo once said, "Mathematics is the language in which God has written the universe." If that's true, then every formula, every geometric shape, and every constant we find might be more than just human inventions. They could be fragments of a divine script, a way for the Creator to communicate through numbers, equations, and patterns. So when we use mathematics to build bridges, to explore space, or to peer into the quantum world, maybe we're not just solving problems. Maybe we're deciphering the mind of God. Part 4. Discovered or invented. Here lies one of the most profound questions in all of human thought. Is mathematics something we discover, like explorers uncovering a hidden continent? Or is it something we invent, like a tool we crafted to make sense of the world? On one side, you have the Platonists. They argue that mathematical truths exist independently of us. The number 7 was always there, even before humans could count. The Pythagorean theorem was true long before Pythagoras was born. According to this view, math is eternal, outside of space and time, something we stumble upon, not something we create. And if that's the case, then perhaps we are glimpsing into a higher order, a cosmic structure that suggests intelligence behind the universe itself. On the other side, you have the nominalists and formalists who insist that math is a human invention. Numbers, symbols, equations, they're all abstract tools we've designed to describe the patterns we observe. In this view, math is like a map, useful, precise, but not the territory itself. The universe doesn't know about calculus. It just exists. We invented calculus to describe motion and change. But here's where things get strange. Even if math were invented, why does it work so well? Why does a purely abstract equation written on paper predict the motion of planets, the path of light, or the behavior of particles so small we can't even see them? The physicist Eugene Wigner famously called this the unreasonable effectiveness of mathematics. If math were merely a human invention, we would expect it to break down when applied to reality. But instead, the deeper we go, the more mathematics seems to fit perfectly. It's as though reality itself has a mathematical skeleton, a blueprint running beneath everything we see. So, is math a creation of our minds, or a discovery of something far greater? Some say that asking this very question already hints at something divine. That mathematics is not just a language we use, but a message waiting for us to decode. Part 5. Mathematics and the Quantum World. If there's anywhere that mathematics reveals its almost mystical power, it's in the strange and counterintuitive world of quantum physics. At the atomic and subatomic scale, reality doesn't behave like anything we experience in daily life. Particles can exist in two places at once. They can teleport their states instantly across vast distances through quantum entanglement. They even seem to pop in and out of existence as if reality itself were flickering. None of this makes sense intuitively, and yet, mathematics does make sense of it. In fact, the equations of quantum mechanics not only describe this bizarre realm, but predict it with uncanny accuracy. A single equation, Schrödinger's wave function, can describe an entire quantum system. When physicists test these predictions, the results often match to an accuracy of 10 decimal places. That level of precision is almost incomprehensible. But here's the strange part. No one really understands why the math works. We don't know why a particle collapses from a wave of probabilities into a single outcome. We don't know why entanglement works faster than the speed of light. The math predicts it, reality confirms it, but human reasoning struggles to grasp it. This has led some scientists and philosophers to suggest that the universe itself might be mathematical in nature, that the quantum world is not simply described by equations, but is built out of them. In this view, particles, forces, and even space-time are not the foundations of reality. The true foundation is mathematics itself, woven into existence like code in a simulation. And here's where the idea circles back to something almost spiritual. If mathematics is the code of the universe, then who or what wrote the code? Was it an accident of nature or the mark of an intelligent mind? For some, the answer feels like an echo of divinity. Mathematics as the signature of God, hidden in the smallest particles of creation. Part 6. The beauty of mathematics in nature and art. One of the most mysterious aspects of mathematics is not just that it explains the universe. It creates beauty. All around us, hidden beneath the surface of life, we find patterns that seem almost too perfect to be random. Take the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. It's a simple series of numbers where each new term is the sum of the two before it. Yet this sequence appears everywhere in nature. The spirals of seashells follow it. The arrangement of leaves on a stem obeys it. Even the spiraling arms of galaxies seem to echo its rhythm. Why does nature choose these numbers, as if following an invisible law? Or consider symmetry. From the delicate wings of a butterfly to the crystalline perfection of snowflakes, symmetry reflects a mathematical harmony that living beings naturally find beautiful. In fact, human perception itself seems wired to appreciate mathematics. We instinctively see beauty in proportion, balance, and order. The ancient Greeks knew this well. They believed the golden ratio, a number derived from geometry, represented the very essence of perfection. They built temples like the Parthenon using its proportions, and artists through history, from Leonardo da Vinci to modern architects, have used it to create beauty. And it isn't only in nature or architecture. Music itself is mathematics made audible. The notes that sound harmonious to our ears correspond to precise ratios of frequencies. A simple octave, for example, is a doubling of vibration. Chords, scales, and rhythms all reduce to mathematical relationships. Yet when combined, they produce something that feels emotional, even transcendent. So, the question arises, why does mathematics generate beauty, both in nature and in art? Is beauty itself evidence of an underlying order? Could it be that our minds resonate with these patterns because we are, in some sense, part of the same design? For some, the elegance of mathematics feels like a whisper of something greater, an unseen intelligence embedding beauty into the very fabric of existence. If math is the language of the universe, then perhaps beauty is its poetry. Part 7. Mathematics and the possibility of other dimensions. If mathematics is the language of the universe, could it also hint at realities beyond our perception? For centuries, humans believed the world was three-dimensional: length, width, and height. But mathematics has continually expanded that vision, suggesting there may be far more than meets the eye. In the early 20th century, Einstein's theory of relativity added time as a fourth dimension, weaving it together with space to form what we now call space-time. This wasn't just theoretical. Predictions made through these equations, such as the bending of light near massive objects, were later confirmed by astronomical observations. Mathematics had revealed a hidden truth about reality that human senses could never detect on their own. But it doesn't end there. Modern physics, especially theories like string theory, propose that there may be up to 10 or 11 dimensions. These are not dimensions we can easily visualize. They may be curled up, invisible, and unimaginably small. Yet the math works. Without these hidden dimensions, the equations fail to describe the universe as we know it. This raises a haunting question. If dimensions beyond the familiar three do exist, what might they contain? Could they hold parallel realities, unseen forces, or even forms of life entirely outside of our comprehension? Some physicists speculate that what we call the laws of physics in our world are just the rules of our particular dimension, while others could operate under entirely different laws. And it's not just physics that hints at this. Geometry itself, abstract, pure mathematics, predicts shapes and spaces that cannot exist in our ordinary three-dimensional world. They are perfectly logical, yet alien to human perception. Here's the mystery. Mathematics leads us there. No myth, no legend, no guesswork, just equations. It's as if the universe is gently nudging us, saying, "There is more. You just haven't seen it yet." So, is mathematics revealing these hidden dimensions to us, or is it simply a tool we've created that coincidentally works? Either way, the suggestion is mind-bending. We may be living inside a far richer, more complex reality than we ever imagined. Part 8. Mathematics and the multiverse theory. If mathematics already suggests hidden dimensions, then the next leap is even more astonishing. The idea of a multiverse. Could our universe be just one of many, existing within an infinite cosmic ocean? The seeds of this idea come from quantum mechanics, the strange branch of physics where particles can exist in multiple states at once. When equations are applied to this behavior, some interpretations suggest that every possibility actually happens, splitting reality into countless versions of itself. One world where you are watching this video right now, and another where you are not. A universe where life developed just as it did here on Earth, and others where it never did. Mathematicians and physicists argue that these aren't just wild speculations. They are logical consequences of the math itself. The equations don't forbid multiple universes. In fact, in many cases, they seem to require them. Take inflation theory, for example. The idea that the universe expanded faster than the speed of light just moments after the Big Bang. If the math behind this theory is correct, it suggests that our universe may be only one bubble in an endless sea of other universes. Each bubble could have different laws of physics, different constants of nature, and even different geometries of space and time. For some thinkers, this is the ultimate proof that mathematics is something deeper than a human invention. If numbers and equations are capable of predicting not just what we see, but realities we may never directly observe, then perhaps they are woven into the very foundation of existence. Yet here lies the paradox. We can write equations describing the multiverse, but we may never be able to test them. How can we step outside of our universe to prove others exist? This has led some scientists to argue that the multiverse is not science, but philosophy. Others counter that it's the natural result of taking mathematics seriously. So the question becomes, is mathematics guiding us to truths about infinite worlds, or simply mirroring the limits of our imagination? Either way, the possibility that we are not alone, not just in the galaxy, but in existence itself, remains one of the most breathtaking ideas mathematics has ever revealed. Part 9. Can mathematics describe consciousness? If mathematics can map galaxies, predict the future paths of planets, and even describe the strange world of quantum particles, then the question arises, can it also explain the mystery of the human mind? For centuries, philosophers argued that consciousness, the awareness of being, was beyond numbers. How could equations capture love, pain, memory, or the very sense of self? Yet, in modern times, scientists and mathematicians are daring to ask, maybe the mind is not outside mathematics, but one of its most profound expressions. Neuroscience has shown us that the brain is a network, billions of neurons connected in intricate webs. The firing of each neuron follows physical laws, which can be modeled with mathematical functions. Patterns emerge, waves of thought, rhythms of sleep, even the way memories form and fade. Some researchers believe that consciousness might be nothing more than the complex mathematics of information flowing through the brain. But what if there's more? Certain mathematical theories, like integrated information theory, suggest that consciousness arises when information in a system reaches a specific mathematical threshold. In other words, awareness is not magic, it's math. This idea shakes old assumptions. It implies that consciousness is not limited to human brains. A sufficiently complex computer, or even the universe itself, might one day be considered aware if the math fits the right pattern. Imagine a cosmos where consciousness is not an accident of biology, but a fundamental mathematical property of reality. And yet, there are skeptics. They argue that no equation has ever truly explained what it feels like to be alive. Math can describe the mechanics of the brain, but can it capture the experience of joy, sorrow, or love? Or is consciousness the one domain where numbers reach their limit? This debate touches the very heart of the mystery. If mathematics is indeed the language of God, then perhaps consciousness, the deepest part of us, is the most divine equation of all. Part 10, the final question. Is mathematics truly the mind of God? We've traveled through ancient philosophy, sacred geometry, the precision of nature, and the mysteries of consciousness. At every step, mathematics has been there, silent, invisible, but undeniable. It is the rhythm of the planets, the hidden order in chaos, the code behind life itself. But here lies the ultimate mystery. Is mathematics something humans invented, or something we discovered? If it is merely a human invention, then it is a tool. Nothing more than a clever system of symbols we created to describe the world. But if it is discovered, if these patterns exist whether or not humans are here to notice them, then mathematics is something far greater. It is the blueprint of existence. Great minds have leaned toward this second view. Galileo said the universe is written in the language of mathematics. Einstein often wondered if we are simply reading God's thoughts, equation by equation. And modern physicists continue to be stunned by the unreasonable effectiveness of mathematics. How formulas written on a chalkboard can predict things we had never seen, like black holes or the Higgs boson, long before they were discovered. So the question remains, why does math work so perfectly? Why should human logic align so flawlessly with the structure of reality? Unless, of course, reality itself is logic. Unless the laws of mathematics are not separate from existence, but the very mind of the universe itself. Perhaps this is what the ancients intuited when they spoke of sacred numbers. Perhaps this is why mystics believed that to study math was to touch the divine. And perhaps, just perhaps, when we write equations, we are not inventing symbols, but glimpsing the thoughts of God. The final truth may never be fully answered. But maybe that's the beauty of it. Mathematics is both a mystery and a mirror, reflecting not only the universe, but also ourselves. And every time we solve an equation, every time we unlock a new law of nature, we may be taking one step closer to understanding the mind of creation itself. So I leave you with the question, is mathematics simply our language for describing the universe? Or is it the very language the universe used to describe itself?